A tiny problem. Well, actually, it ended up being a great help for me. A great help for me. So we have a tiny problem, though. Well, we don't. Let's rephrase it. Your grade's about to have a tiny problem. You know those first, 8 papers I graded? I don't know what you're flagging at me. You know you need to put that in the box. Okay. That grade of yours, that was supposed to be so awesome. And then I took my time this morning during zero period, no go back to nothing. So I graded some more of those tests. Let's see the scores of the tests I did grade. Now, again, the high A's and B's have already seen theirs. I don't know why the high A's and B's were the first 8 turned in. That's weird. Let's see. I got a 59. I got a 70. I got a 61. I got a 63. I got a 54. I got a 57. I do have a 93. And I got a 58. Do those sound like lovely scores to you besides that 93? No. Do you want to know why those people have those scores? You want to know what they did, which made my life super easy to grade? There were 18 questions on your test, right? So 5 points each. So if you skipped a question, you lost 5 points each time you skipped a question. I had somebody who skipped 1, 2, 3, 4, 5, 6, 7 questions. Well, 7 times 5 is 35. So that person already missed 35 points. Or let's rephrase that. That person already chose to miss 35 points. And then, of course, because he or she is not perfect, they made mistakes otherwise. And, of course, 35 is almost to 40. And if you're at minus 40, you're right at a 60. So that person only had 5 points to spare. So I'm actually pretty impressed that that person only got 7 points more than that. It's pretty impressive, honestly. You skipped that many and still ended up with 58. That's pretty impressive. I'm not even going to lie. It's pretty impressive. Who leaves a question blank on a test? That is the silliest thing I've heard of in my entire life. I can feel sorry for you if you do some math. I cannot feel sorry for you when you leave it blank. Okay. I also can feel sorry for you when you just have a blind moment. You put right 7 and you meant up 7. I take off 1 point. No big deal. If you put no words to describe the transformation, then how do I know that you knew that meant right 7, up 7, left 4, down 4, reflected, dilated, any of those words? I don't know. It was really concerning. But you know what? We'll get to that in a moment. When we get done teaching those that I have graded, we'll get to see theirs. I have about 6 left, and I should be able to finish them by the end of class. That way everyone knows what they made on our test from Tuesday. But I was so excited I was going to have first periods done. Man, I pray second and third period did a little bit better than that, because that really hurt my feelings, guys. I'm not going to lie. That really hurt my feelings. But I mean, it didn't look like you didn't know what you were doing. It just looked like you felt like skipping some problems. Oh, Lord. Okay, so we're going to move on from that. We're going to hope brighter and better things happen. I have not typed in that ugly score yet. It's going to, if you're one of those ugly numbers I typed out, it's going to drop your grade. So what are you doing to fix that? Oh, well, of course you come to zero period, but let's talk about other things, because people don't tend to come to zero period, Gracie. Let's see. Are you grading your group points? Because there's not a limit of only getting 5 points. Your group could get 10 points today. I don't care. Your group could go over the 5. But if your group's not even getting the 5, then you're missing out on an easy 30% grade. All because you wanted to play on your phone during class. Woohoo. And then we have 2 60% grades left. What are they? The test Tuesday, what is it on? Yes, and you can have a point for that. Math workshop test is on Tuesday. We are also going to take a quiz on Tuesday on 3.1. It's not a quiz, we're calling it a test. My bad, let me rephrase it. A test on Tuesday on 3.1. Yep, just one section. On graphing, substitution, and elimination. We talked about graphing 2 days ago. We talked about substitution yesterday. We're going to talk about elimination today. Yeah, I know we're flying. Again, this is all review stuff you were supposed to learn. You had a couple pages from your workbook you were supposed to do last night. I've added to that list today. So now you're up to 1, 2, 3, 10, 11, 7, 8, 12, 8 problems. My gosh, life is so hard. There are 8 problems on that board that I expect you to get done. And really, Mackenzie would like to show them to me before she leaves class today, because she don't want to have homework this weekend. And she knows I'm going to type in that 0 on Monday. And she didn't have time to deal with any zeros when it's the last week of the 9 weeks. There's also, when I get done rambling any on to you, there's also a checkpoint today on substitution and graphing. And if you think I eventually just give you a perfect score just because I love you, I don't. So you need to get that checkpoint done and accomplished, because eventually when you give up on me, I give up on you and type in the 0 for you. Yeah, some people have had zeros before on checkpoints. They may or may not realize that they got zeros. Okay, let's get this started. That way you can get done what you need to get done, because clearly you need to save your grade while you can. Number 13 of our math workshop. Luna and Sophia are simplifying this equation, or actually it's an expression. Is either of them correct? Explain your reasoning. Yes, Mia.
Well, Luna is correct, but Sophia put the letters that it's 6 times B, but then she put 6A.
Oh, okay. So they both tried to distribute. She got 56A. She got minus 40B. Sophia also got the 56A and minus 40B. But on the next line, Luna got negative 6B, negative 20, yes. Ooh, Luna made a mistake too, didn't she?
Yeah.
Mia get 2 points, because that was a good answer. But Luna made a mistake too. She should have gotten a negative 24 here. Negative 6, positive 4. She should have gotten a negative 24. But Sophia also made a mistake. She did swap her letters. It should have been negative 6B and a negative 24A. So they are both incorrect. Now I'm lazy today, so I'm not actually going to write out my reasoning the way I should. But if I were to, I would explain when Luna distributed, she should have gotten a negative 24. And when Sophia distributed, like Mia said, she swapped her variables. So both made tiny mistakes, and sadly those tiny mistakes add up. They do. Okay, 14 is super duper hard, so we're going to break it up into parts. It's really not that hard, but we can break it up into parts anyway. I need to know an equation for that green line. I need to know an equation for that green line. Where is its intercept? If you wrote it in y equals mx plus b, what would you write?
Negative.
And I know you're going to say 3. Good. It is at negative 6 with the intercept. Perfect, and you get a point for that. But I need to know that slope. Some number needs to go in front of that slope. Let's see, up 6 over 3. Say again, Hunter? Yeah, I think it's up 2 over 1, because if you went up 6, you went over 3. 6 over 3 is 2 over 1, so I think it's 2. 2 over 1. Hunter, you get a point for that. So we wrote an equation for that green line, and we'll come back how to write it as a system of inequalities, and actually we'll do that slowly, one bit at a time. When they shaded this, so I need to change it from an equal to sign because it says inequality. When they shaded, did they shade above this line, below this line? Look at where it's shaded. Was it above or below? It was above. Kelsey, you can get a point. And they shaded above the line, so we should have a greater than or equal to. How do I know it's an equal to? I heard it, and I don't know who it was. Faith, because it wasn't a dotted line. I got like 4 people in here who don't know when to do dotted or solid. If it's not equal to, you can't do a solid. You cannot. Okay, so that's my green line. Now let's deal with my pink line. Yes, ma'am.
But you're going up by 2s, right?
8.
Yes, up 2 over 1.
So it would be really, in it, because fourth the line's two apart.
Yes, so 6 to 3. That's why he said 6 over 3 is 2 over 1.
Okay.
Okay, now with my pink line, where's my intercept?
4.
It's crossing at 4. I'll sure you get a point. It's a positive 4, and I've got to figure out a slope to put in front. What is the slope of that pink line? It's obviously negative because it's leaning to the left. Yes, dear.
Down 1 over 2.
It is negative 1/2. Because you would go down 4 over 8. So minus 4 divided by 8 Negative 4 over 8 is negative 1/2. So that is correct. Okay, and then it's not y equals, but I'm going to put equals for this moment. When they shaded, did they shade above or below that line? I heard it, Mackenzie. Was it you? I thought it was Mackenzie first. Mackenzie gets the point. Okay, and it's below the line, so it needs to be a less than. So we wrote an equation for the green. We wrote an equation for the pink. And now we've got to write an equation for the, I got to use one more color, for the purple. Okay, let's look at the purple. Where's its intercept? Thank you, Hunter. You can have a point for that. It's also at negative 6. Okay, I need to know the slope of that purple line. It's positive. Oh, nope, it's negative. It leans to the left. Say again, Hunter. Up 1 over 1? I don't think so. I mean, I would go up 6. Yes, I think it's 3, and table 1 gets a point. Okay, I think it's, if we were down at negative 6, if we went up 6, and then left 2, that would be 6 over negative 2, which is negative 3. So it's negative 3. Okay, and then let's think about where did they shade. Was it above that line, below that line? Where did they shade?
Below.
They shade below that purple line? Above. So we're going to make it greater than or equal to, because again it was solid. So it said write a system of equations. Whoa, Lord Jesus, help them get it together. It said write a system of equations, which means a system just means it has the same variables. We used y's next to each time, so we've got this system down. We wrote an equation for each line. We took it one step at a time and considered where they shaded. What region did the 3 lines make with their shading? You can have another point for that, Hunter. Okay, go to your notes. Unless there are any questions about that. That one was a hard one, but again, if we take it one equation at a time, it's really not that big of a deal. So, we talked. Get your laugh together. You better be glad I don't take a point away for that. That was ridiculous. We talked 2 days ago about 4 vocab terms. What are those 4 vocab terms? Thank you, Kelsey, for saying the list. I'm sorry, I should beat you, baby doll. Okay, so consistent, inconsistent, dependent, and independent. If I have no solution whatsoever, what word will I use? Inconsistent. I heard it from table 6 and 3, so add a point. If I have 2 parallel lines, what words will I use? Oh, it's the same thing. No solution and 2 parallel lines. I'm still going to say inconsistent. I heard it from Day, the loudest. Day, get your point. Okay. What if my 2 lines cross at exactly 1 point, and that point is special? What 2 words will I use? Consistent and what? Independent. Okay, and then if we have infinitely many, we'll say consistent and dependent. So if it's special, it's independent. If it's not special, it's dependent. Okay, you have to know those vocab terms. So if when you're graphing, so the first thing we know is the graphing one. If when you're graphing, you don't actually put the vocab terms, you, like many others on the last test, have not followed directions, and you will miss out on your points. And why are we surprised? We should not be surprised. You will miss out on many points if you don't add those vocab terms. Okay, so we talked about that, and then yesterday we were working on substitution, and we did an example that had a solution. We did another example that had a solution, and we discussed our solution has to be an ordered pair. So Seth gets excited when he gets just y equals some number, but if he doesn't plug it back in and get the number for x as well, he's not done. You have to have an ordered pair. Okay, we finished number 3 yesterday, and then I said we'd come back and do number 4. I actually want to do a different one than number 4. I want to discuss number 4, but we're not actually going to do it. Okay, why is number 4 different from the other problems we did yesterday?
So they're the same thing, like the same, why didn't you go with
What's the difference with number 4 than the other 3 problems we worked yesterday?
A and B.
Yes, it's the variables, and I'm going to give you the point, Addison, since you need a point, so I'll give you a point, because I think Mackenzie said it too, but I'll give you the point. You don't care. Okay, so if it's an ordered pair, we know X was normally the first value, Y was normally the second value. If we're using A's and B's, what's the first, what's the second? A is the, and then B is the, and you can have a point for that page. Okay, so we're not actually going to work number 4. It's just important to note that we don't have to use X's and Y's. We can use any 2 alphabetical letters. The first letter is going to be the earliest letter in the alphabet. The second letter is the second. So if Hal works a problem with M's and N, M would be the first variable, N would be the second. Put it in alphabetical order. The one that comes first is the X coordinate. The one that comes second is the Y coordinate. It's just so you can know that we don't always have to use X and Y. Okay, the reason I don't want to work this example is because it actually has a solution. If you want to do it later, you can. The answer is -4,6. I don't want to work this problem. Instead, I made up one of my own. So I want to work, it's a system, we're going to call it number 5. I'm adding it in. We're going to do, my first equation is easy. It's y equals x plus 4. My second equation is a little complicated. -2x plus 2y equals -10.
I got you.
Okay, so I've made up this problem. So we practiced 2 that had a real solution yesterday. We practiced 1 that had an infinitely many. What do you assume I did with my problem? We did 2 with real solutions, 1 spot. We did 1 with infinitely many. What do we assume this one's going to be? Yes, Braxton. Consistent dependent would be infinitely many. We've already done an infinitely many. Eduardo. We are going to work an inconsistent problem. This problem is inconsistent, which for those of us who still don't have our vocab down, that's my way of saying this is supposed to be a no solution problem. We're not supposed to reach a solution on this one. Okay, so yesterday we discussed substitution. One of these equations is set up perfectly for substitution. Which equation are we going to use to substitute? Which one is set up so we can use it to be the guy to plug in? The first one, because we have y equals. How nice that they've already set it up for us. We know who we're going to replace. We're going to replace y with x plus 4. So in that second equation, everywhere I see a y, I'm going to put x plus 4. Okay, so that seems great. We've substituted, and I know I'm right here because my equation has only x's. So I've substituted correctly because I've gotten rid of one of the variables. Okay, and then when I distribute, I'll have -2x plus 2x plus 8 equals -10. What's -2x plus 2x? 0, so it goes away. So we end up with 8 equal to -10. Is that true? No. If you end up with something crazy that is not true, that's when you know you have no solution. So you're like, Miss Compton, that really reminds me of number 3. Let me see if I can get a book. Yes, it is inconsistent. Okay, so that really reminds me of a number 3 that we worked yesterday. Because similarly, in our problem, the x's went away. In that problem, the y's went away. But in that problem, we ended up with a true statement. 18 equals 18. That's legit. That's why it's infinitely many. In our problem today, we ended up with 8 equals to -10. That's complete crap. That's why it's no solution. If you end up with something legit, infinitely many. If you end up with something that's crazy, no solution. Okay, are there any questions about either of those? Okay, then today we're going to discuss my favorite option. I like elimination the best. When they let me choose what I want to do in life, I choose elimination. And here's why. Elimination is perfect if your equations are set up in standard form. So maybe I wouldn't choose elimination with that made-up problem I just made because my two equations weren't in standard form. But in number one below, both in standard form, I choose elimination. So if you get to choose and they're in standard, I tend to choose elimination. Okay, elimination sounds like something we can handle. What does it mean if you eliminate?
Take away.
Yeah, you eliminate, you take away, or, we're going to kill something off. We really are. Our goal is to kill off one of the variables. We want them to go away. So what we're trying to do is figure out, is there a number we can multiply either the top equation by, the bottom equation by, or maybe both? Is there a number we can multiply by so that one of the variables dies? And in this one, it's really easy. There's a number we can multiply that top equation by that when we put it with that bottom equation, people will die off. What number should I multiply the top by? Say it again. 3. I multiply by 3. 3m, 7m, they're not going to go away. Negative 3n, 2n, they're not going to go away. I'm really wanting to have like a positive 7n and a negative 7n, or a negative 2n and a positive 2n. So with this one, I don't even tell you, so we're starting off, pages like, just tell me this time. I would multiply by 2. Okay, so if I multiply by 2, that top equation now says 2m minus 2n equals negative 18. So I multiplied everybody on that top line by 2. Okay, why am I doing that? Because now, when I write that bottom equation again, 7m plus 2n equals 9, I'm literally going to add them together. But the coolest thing's going to happen, because the n's are going to be eliminated. They're going to die. So negative 2n, positive 2n, that dies. I have 9m equal to negative 9. So m equals to negative 1. So let's say all the words again. I like elimination more than I like substitution. Pick a number that would help us. We multiply that top equation by 2. The reason we did that is now these are opposite signs, so they die off. Positive 2n, negative 2n, they cancel each other out. We add straight down. 2 plus 7 is 9, so 9m. Negative 18 plus 9 is negative 9. If I divide by 9, I get m equals negative 1. Okay, you and I both know I'm not done, because that's not an ordered pair. But my gosh, how fast that was. To me, that's so much faster than the substitution. And really, kind of so much faster than having to rearrange my equations and graph. So this is my go-to guy. Okay, you can pick either equation to plug it back into. You can pick the new one we multiplied by. You can pick one of the originals. I think I'm going to go with the top original just because it has very little extra stuff. It's not 7m, it's just m. So I'm going to plug, it was m minus 9 equal to negative n. We just found out m is negative 1. So I'm going to have negative 1 minus n equal to negative 9. I add 1 to both sides. I'll have negative n equal to negative 8. If I divide by negative 1, I'll get n equal to 8. So my answer is the ordered pair, negative 1, comma 8. Not infinity, Miss Compton. Negative 1, comma 8. So it kind of is like substitution, and once you figure out one of them, you just got to plug it back in to figure out the other one. But in other ways, it's so much faster than substitution, because if it's in standard form, my gosh, we just multiply by a number, cancel people out. It's great. Okay, let's see. I want to go to number 2. Number 2 is a little harder. There's not a magic number. I'm going to have to actually multiply both equations by a number. So, because there's no way I can turn that 2 into a 3. There's no easy way to turn that 4 into a 6. So I've got some options. You could either multiply that top equation by 3, multiply that bottom equation by negative 2. You would end up with a positive 6x and a negative 6x, and people die off. I'm just thinking in my head, who do I want to die? Do I want the x's or do I want the y's? If I decide I want the y's, well, 6 and 4 both go into 12. So I could multiply the bottom by 2, the top by 3, and then I'll have a positive 12y, negative 12y, and they'll cancel out. So I could pick either variable. since we just did the first, I'm going to do y's just for fun. But if Mackenzie understood what I said, she can get the x's to link to. Doesn't matter. Okay, so I'm going to multiply the top by 3. And I'm going to multiply the bottom by 2. But again, when I'm thinking through what to multiply by, I'm thinking about who I want to die. I want the y's to die, so I need it to be 12y, negative 12y, because I want them to be eliminated. So that's why I'm picking the numbers I'm picking. Okay, my top equation would read 6x plus 12y equals 54. And my bottom equation would read 6x minus 12y equals 6. Are there any questions about this? Okay, most people make 2 mistakes when it comes to elimination. 2 common mistakes. Can anyone guess one of the common mistakes people make when it comes to elimination? I see both mistakes could potentially happen or could have happened in this problem. So signs is a big issue, and you can get a point for that. And I think Seth was trying to say the same thing, so we'll give him a point too. Some people think positive 6, somehow the x's are going to cancel out. They have the same sign. How can anyone be eliminated? One of them has to have the opposite side in order for someone to be eliminated. So that's the first mistake. People eliminate people who shouldn't be eliminated. The 6 x's aren't going to go away. One's not positive, one's not negative. It's not going to happen. Okay, and then the other mistake people make, it's really very algebraic. What were we doing when we made this equation? What did we do with that 2 in order to get to here? What's that mathematical property? Yes, Kelsey. Kelsey, you said it first. Point. We were distributing. So Seth gets in a hurry because, my God, we all get in a hurry. He does 2 times 3, he gets 6. He does 2 times negative 6, he gets negative 12. But he's in a hurry, so he forgets to do 2 times 3, and he just writes the number 3 in. So you're like, Miss Compton, oh my God, that's me. I'm the one who forgets to distribute. I do that kind of thing all the time. It's okay. Just like yesterday, Scout's honor, I promise. If it's not going to be a pretty number, like 3, negative 4, that kind of a pretty numbers on the test, it's going to be decimals or something crazy. I'm going to tell me in advance. P.S. This one's crazy. It's okay if you get a decimal. I will tell you in advance. Okay, so let's eliminate. The y's die. 6 plus 6 is 12, so we have 12x equals 54 plus 6 is 60. I divide by 12, I get x equals 5. I can pick, and that is easy. I can pick either equation to plug it back into. I'm going to go with, doesn't matter, I'll pick top just because it's on top. It really doesn't matter. So it was 2x plus 4y equals 18. I'm going to do 2 times 5 plus 4y equals 18. So I have 10 plus 4y equal to 18. 4y equals 8, so y equals 2. My point is 5, 2. Okay, are there any questions about this? Then let's go to number 3. And we're about to get super excited. We're not going to do all 3 through 7. I have specific ones I want to work. One of them is number 3. One of them is number 3. Okay, so we look at number 3. And we get kind of excited for 2 points. There's an easy number I can multiply that top by. What is that number? Yes, ma'am. 2. You get 2 points. If I multiply that top by 2, I'll have 4x minus 2y equals negative 8. And on the bottom, I will still have negative 4x plus 2y equals 6. And then Paige gets super duper sad. Why? What happens?
Both x and y's get cut out.
So they're completely gone. X's died, y's died. I have negative 6 plus 8.
Negative 2.
So I have 0 equals negative 2. Is that a legit statement? No. So we're going to assume this is a no solution. We're going to assume this is a no solution. So what were the words we were supposed to put with no solution? Thank you for knowing your vocab. Inconsistent. Every group can have a point. Inconsistent. Okay, let's do number 5. I want to go to number 5. We might come back to 4, but let's go to number 5. Number 5, what do I need to multiply the bottom by? If I multiply that bottom by 2, my top line is 2t. Seth, I heard you for it first. You can have the point. That bottom line would say negative 2t minus 4v equals negative 6. Okay, and oh my goodness, that same thing happens again. The t's are eliminated, the v's are eliminated, but what happens this time?
The 6's are eliminated.
So you want to put that, don't you? But since these are eliminated, we have 0 on the left, right?
Yes.
What's 6 minus 6?
0.
So is that a true statement?
Yes.
Yeah, yes it is.
So what should I put instead? It's not inconsistent. It's consistent and because it's infinitely many. Perfect. So it reminds me of substitution, because if you end up with something crazy like we did before, 0 equals negative 2, well, that's not true. No solution. But with that one, we ended up with something legit. 0 equals 0. Hey, that's true. Infinitely many. Okay, let's go to number 7. Number 7. And if we get that one done pretty quickly, we'll call it a day and let you take your checkpoint. What should I multiply the... Let's fix the top one. What should I multiply the top one by? What should I multiply? 2? The top I should multiply by 2?
4.
They already have the same numbers in front.
Eliminate them.
They can't be eliminated. They're not the different signs. Who said it? Thank you, Faith. If we multiply by negative 1, we would have negative 2r plus 3s equals negative 11. And then my bottom equation stays the same. 2r plus 2s equals 6. And again, if you were just immediately trying to eliminate, you made one of those 2 cardinal mistakes. They have to have opposite sides in order to be eliminated. When we started off, they were the same sign. Now they're opposite, so we can't actually eliminate. So the r's die. We have 5s equals negative 5. So s equals negative 1. We can pick either equation. I'll pick the bottom one. 2r plus 2s equals 6. We just decided s was negative 1. So 2r minus 2 equals 6. So 2r equals 8. So r equals 4. And now we run into that debate. Which letter comes first in the alphabet, R or S?
R.
Every group can have a point. So it should be 4, negative 1. And yes, I'm going to take a point away from Addison on the test if her alphabet skills are not on point, because if she puts negative 1, 4, she technically has a different ordered pair. Okay, are there any questions about that? I added 3 problems to your list that were from your workbook. I need to give you this checkpoint. My God, I wish you would have it done before you leave this room. I understand that we're a little on time today, so you might not. You're not that good. I wish you were.
I think we need to like 3.
I think you're that fast, but I've been wrong before.
I'm fast.
No, why don't you? And Kate is on it. God, she's on it. She got another point for that. I don't want to see. Show me when you have all 3 done now, because I'm just gonna do it with 1 grade. Because let's face it, it's like 8 problems. The faster you get it, the better. We'll stay Monday, but the faster you get it, the better. Yes. I'm about to pull that up. Let me stop my recording and I'll have it up. A minute, apparently.